All right, hello people watching this video. This is day one of the Calc semester review. They have decided that since we just got done doing limits, that we're going to start with limits. So we're going to work back to front, especially because the first chapter that is on here is chapter 9. And the fact that there's 3 of you gone right now, we want to wait and do that one together because that one they said might be the one that's the hardest to go through. So we're going to start from back and work to front because this is limits. This is what we just got done doing. So here we go. 45. Always want to plug it in if you can. Should we write the steps down here? Number 1. Okay, always for limits.
One piece. No.
Always for limits. Try to plug it in to begin with. Okay? If you can't plug it in, then we either divide or factor. Okay?
Plug in.
Or another strategy could be that we rationalize. Okay? Or a fourth strategy could be that we look at the graph, right? If they already give you the graph, then you're definitely going to look at the graph. I don't think I give you the graph right now.
The graph is probably the easiest way to do it.
But the graph is what you're going to want to use when you have like parent functions like 1 over x and 1 over x squared. So, or any deviation of that, right? So if you're looking at that, 1 over x is going to be a boomerang that looks like this, okay? So you're looking at those. And 1 over x squared is the volcano-y thing, okay? So you're going to look at that stuff, okay? What?
3 is rationalized.
Oh,
3 is rationalized.
He doesn't know how to spell it. It's okay.
Okay, good. Those are your strategies. Okay, let's talk about, I'm also going to put down here continuity. C-O-N, continuity. Continuity, okay? There are 3 things that can make a function not continuous.
Holes.
Holes and vase.
Okay, holes and vase. Number 1, we'll do hole. Number 2 is a va. And number 3?
Aha. A saw. A saw.
Piecewise.
Is a piecewise function that has different y coordinates. Right? So when you plug it into like the top equation or the bottom equation, they will not match up with one another. Okay? So those are where it's not continuous. Now, out of these, which one is removable and non-removable?
The va is non-removable.
Okay, these 2 are both non-removable.
The piecewise is non-removable. The whole is removable.
Okay, a hole is removable. Okay.
I don't even remember like anything in chapter 9 other than
Okay.
we have like a pink circle or something. Like jeez, it's gonna be rough.
You mean your unit circle?
Yeah.
Sarah, do you want to know something?
What?
I've got 10 fingers. 2 of them.
You're silly. All right, now, out of these, let's write down one more thing. So I'm going to say will always have limit. Will always have limit. Sometimes have limit. And never have limit.
Didn't make more room. Wow, this is.
Or in other words, the limit will be infinity or negative infinity. Okay? All right. Which one of those 3 will always have a limit? This thing will always have a limit because left and right will always end up matching up to be the same.
Vase.
No.
Holes.
A hole will always have a limit,
Holes. Holes.
right? Because you can remove it out and you can plug it in, right? It will always have a limit. Okay? Which one of them will never have a limit? It will always go to infinity or negative infinity.
Va.
Okay, va. Because it'll end up going like this, right? It'll either go to infinity or negative infinity, so it will not have a limit. A piecewise function is the one that will sometimes have a limit, okay? All right, so piecewise. When will it have a limit?
When the pieces match up.
Yes, when the y coordinates are the same. When the y coordinates match up. So when you plug it into the top and plug it into the bottom and they are the same value, right? It will not have a limit if the 2 sides disagree. Does this make sense? When your two sides disagree with one another is when you will not have a limit for a piecewise function. Otherwise, a whole will always have a limit. A va will always be either infinity or negative infinity, which technically does not exist. And then if the two coordinates are different, you'll have a DNE for piecewise. But if the two coordinates are the same, then you will have a va, or will have a limit. Got it? All right, let's do some problems. Here we go. Number 4 or 45. Starting here.
Flaming races.
You can't plug -4 in.
Flaming races.
What strategy are we going to use for this one?
Graph it.
You know,
Graph it, okay? This is,
very racist.
what does this thing look like?
1 over x.
This is like 1 over x, right?
Left
Okay?
4 and
The 4 makes him left 4. 1, 2, 3, 4. And the 3 just makes him more of a C and less of an L. So he's going to look like this instead, right? Okay? So as we're going to -4, okay? -4, if we do -4 from the right and -4 from the left, what's -4 from the right going to be?
Positive infinity.
Positive infinity. What's -4 from the left going to
Negative infinity.
be? Negative infinity. What's -4 in general?
Not a thing.
Does not exist because they are not agreeing with one another. Okay? Does not exist.
oh,
That's a va. He doesn't exist. Good? So that one was strategy 4. If we need to write that down. Strategy number 4. Okay? That was a look at the graph thing. Okay? Good?
Yeah.
All right. 44. I'll zoom out. 44. Find the values for which it is discontinuous. Okay? Things that are discontinuous are wholes and vas and piecewise functions. This is not a piecewise function, so we're looking for wholes and vas, right? Okay? All right. So I look at the bottom. X squared minus 4 is x plus 2, x minus 2. Okay, now before you cancel stuff out, set it equal to 0. So x equals -2 and x equals +2, right? Out of those two, which one is a whole?
x equals 2.
X equals 2, right? This is a whole, which means it is removable. This one is a va, which means it is non-removable. Got it? Okay. Now we will say that it is discontinuous. Discontinuous at
Negative.
both of them. It's discontinuous both places. Whether it's a whole or a va, it's still going to be not continuous because my train's going to run off the tracks. So regardless of whether it's a whole or a va, it's both continuous. One is removable and one is non-removable, though.
So
Okay.
it's removable.
If it's removable, then you can find the limit there,
Okay.
right? If it's non-removable, then it'll have an infinite limit. Okay?
Okay.
Good?
How do you like my hair?
All right, find the limit here. This is 1 from the left. 1 from the left. Which equation is 1 from the left? What?
2x or x squared plus 4.
X squared plus 4. So what's the limit at 1?
5.
5. I just plug it in, right? 1 squared plus 4 is 5. So that's the limit from the left. Okay? All right. Okay. Number 42. Find all values for which f composed of g of x is discontinuous. Okay, so let's plug g of x into f of x. Let's plug this guy into there. Okay. Oh man, this is crazy. 5 over, okay, x to the 4th minus 1. Okay, discontinuous. Things that are not continuous are wholes and vas. Is he going to have a hole?
Nope.
No, he's not going to cancel with 5 on the top, right? Okay, but vas, let's set the denominator equal to 0. Okay, or do you want to set the denominator equal to 0?
It's more.
What?
What happens if we
Kind
put
of.
it to
You
0?
find a va.
I mean, that's two different ways. Technically, this is a difference of squares, right? It's actually x squared minus 1 and x squared plus 1, right? But then x squared minus 1 is also a difference of squares. So it's x plus 1, x minus 1. You see that?
What? What?
Yeah?
Okay.
X to the 4th minus 1 is a difference of squares, but then x squared minus 1 is a difference of squares also. So here x equals -1, here x equals 1, here x equals
Plus and minus 1.
plus and minus I.
What?
Now what?
Why?
Why can't you just add the 1 over and take the 4th root?
That's what we're gonna do. That's what another route that you could do. Okay.
Wait,
So
but then that would
where is it discontinuous at? Looking at those 4 numbers.
Nowhere.
Discontinuous at
Oh,
negative
1
one.
and negative.
1 and negative 1, right? 1 and negative 1. Now, it's also discontinuous at positive and negative I, which is not a thing, right? Okay, now, that's if you do it that route by factoring it down. If you just set x to the fourth minus 1 equal to 0, and x to the fourth equals 1, you take the fourth root. What's the fourth root of 1?
Plus or minus 1.
Plus minus 1, right? So x is discontinuous at plus minus 1. We still get the same answer. It's just we don't get the i's as a result, which really don't mean anything because you can't be discontinuous at an I. So, a couple different ways you have options for solving. Okay, whichever way makes sense to you.
Hold on.
Okay? Good?
What?
Find all values for where it's discontinuous. Perfect. Okay? All right, 41. Find the limit. Can we plug negative 9 in?
Nope.
No.
No. So what's the strategy?
Divide.
This is strategy 2. Okay, so you can either divide or you can factor it. Can we factor it down this top?
Nope.
Yeah, you can.
Yep.
Multiply to get 27, add to get 6. I'm guessing one of them might be plus 9, right?
Negative 3.
9 and negative 3, okay? So those cancel out. So I am just strictly finding the limit as x goes to negative 9 of x minus 3, because that's all that's left over. And now can I plug it in?
Yep.
Yep, and it is
Negative 12.
negative 12. So divide it out
What?
and see what's left over.
No, what? No, what? You what?
Oh, it's negative 9.
What?
Yep. You're plugging in negative 9.
All right.
Yep. Okay? How about that?
Oh, rational.
Okay? The next one. Can you plug 0 in?
No.
No, so let's rationalize. Okay, multiply by
Plus 1 plus 3.
the square root of x plus 1 plus 3 and the square root of x plus 1 plus 3. Okay? All right, if we FOIL the top,
It's just.
it's going to be x plus 1. The middle two pieces cancel out. Do I need to write that?
No.
Okay, and then minus
9.
9. This one has a typo because this is not going to work.
Yeah, I just did it and it doesn't work.
Yep. This is supposed to be minus 8 on the bottom. That's a typo. Ha! I lied.
What?
Instead of it being, well, then we could have just plugged it in to begin with. Nope, wrong. Here's the typo. You ready for the typo? Can I fix stuff?
I guess.
Can I fix stuff?
Yeah, too late for that.
Right here. This should be a 9 right here.
Really?
Oh, boy.
It's fine. That should be a 9. So it should be the square root of x plus 9 minus 3 is what on the top should be. Okay, so when I multiply those out, this should actually be a 9 right here.
Wow.
And then it fixes things. Okay, I've got x on the bottom times square root of x plus 1 plus 3.
I thought it was plus 9. Oh, it is. Okay.
Yep. Okay, so these two cancel, and the x's cancel as well. So I'm finding the limit as x goes to 0 of 1 over that junk.
What?
Yes,
Huh?
1 over the
If
square
there's
root of x
nothing
plus
on the
1.
top, it's 0.
It's 1.
It's
Now it's
1.
If I take away all your cookies, how many cookies do you have left?
Hey, kiddo, what if I do like 4 divided by 4? It's not 0. It's 1 over 1.
You
Child.
stupid head.
I'm totally right.
It's 6.
For sure. Now we plug 0 in, okay? If I plug in 0, the square root of 9 is 3, and 3 plus 3 is 6, so 1 over 6. Sorry about that typo. That should have been a 9 instead of a 1. Okay? Happy with that? Did we get through that after the typo?
No.
That always just
You
confuses people.
lied to me.
I'm sorry.
Kyle's hurt.
I am.
Okay.
My feelings are.
Good? All right, 39. Here we go. Can we plug in 2?
No.
No. So what do we do now?
Yes, and test.
Well,
Yes, and test.
We can foil.
No.
I don't want to
No.
Look at the
Foil
graph.
wants
Look
to
at the
know.
graph. This is strategy 4. This is a graph. Strategy. Number 4. This is the graphing one. What's his parent?
1 over x squared.
Parent.
right 2.
There's 1 over x squared, which looks like a little volcano-y thing. But he has a to the right 2, Rachel said. And it looks like a little volcano-y thing. So this is just saying 2. Not from the right, not from the left in general, but he's going the same direction both times.
Does not exist.
Infinity.
It's infinity, which means does not exist. Okay?
I love those ones.
There you go. Okay?
Is it infinity? Because I'm pretty sure it does not exist because they don't. Because it's not one or the other.
Like it's not the same infinity technically. Yeah, kind of. Yeah, I get what you're saying. Right. Now, if you are using strategy number 4, and you're looking at the graph, the answer is going to be either infinity or negative infinity because like 1 over x and 1 over x squared is going to have Oz. Okay, so that's strategy number 4. All right, 38.
Is it?
Plug it
Oh,
in.
I bet it's 3.
Strategy number
Plug it in.
1.
1.
Ha.
Plug 2 in. 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. And the square root of 9 is 3. Is it plus and minus 3 or just 3?
Just 3.
Just 3.
Why?
Because we didn't do it. It's already there.
Yeah, the square root was already there. So it has like an implied positive in front of it, right? Like it's already implied to be a positive square root. Good? That was limits. Okay?
I like
All right, 37. We did a completing the square this morning for trig. Yay. But it's not the same completing the square.
I don't know.
How do
Oh.
you complete the square?
No, come with you.
Yee.
I don't remember.
You have to like move.
Completing the square is completing the blank. We've got to move the 58 over. Okay? So that becomes negative 58. And I'm going to do plus blank equals x squared plus
Oh, I
6x
see.
plus blank.
I
Right?
never got these.
Wait, can I do it
Alright,
to see if I
pause.
can
Can
know
we
how
pause
to do
for
it?
a quick
Sure.
second?
Yep. We'll pause.
Alright.
We'll pause for a hot second.
Okay, that's negative.
Completing the square is completing the blank.
Alright. So what we do is it'll probably be x.
What is this? What are the blanks?
It'd be 2.
Okay, we have to find out what goes in the blank.
Okay,
Yeah.
how do
X
you?
Okay.
plus 3, x plus 3.
How do you what?
How do you?
How do you
Oh.
do it?
You have to have x.
Okay, so what we have to do is this is a trinomial that I want to be a perfect square trinomial. I want to break it down
6.
into 2 pieces. Okay, so it
X
has to
plus 3.
multiply to give me this number, which I don't know what that number is, and it has to add,
Give me
add to give me 6, but they have to be the same number, right?
X.
So it has to be x plus 3 and x plus 3, right? Does 3 and 3 give me 6?
Yes.
Well, what's 3 times 3?
9.
9, so 9 goes in the blank.
That goes in both blanks.
Both blanks, because I have to add it to both sides, right? In order to keep it remain
Wait,
even.
wait, can I write that down real quick?
Yep, go for it.
So it needs to multiply to be 9, adding it 6.
Yep,
and
multiply to be the blank and add to be
has to
the
be the
B
same
number, right? And it has to be the same number.
So then you get
And you get negative, what, negative 49? Is that true? Yeah, negative 49, okay?
Yep.
And the reason why I want it to be the same is because the very next step is writing it as x plus 3 squared. I can't write it as x plus 3 squared if they're 2 different numbers, right? Okay, and then equals negative 49. Okay, then what?
You take the square root.
Take the square root, right? Okay, what's the square root of negative 49?
7i.
Yep, 7i, but we need
Plus or minus 7i.
plus minus 7i, right? Because we put the square root in there, okay? Last step,
Minus 3.
minus 3. Can you subtract 3 from 7i?
no.
No, so I'm going to say x equals,
Plus minus 7i plus.
I'm going to do minus 3 plus minus 7i. It doesn't matter how you write it. You're technically right either way, but I always put the I or the square root part last. Okay? Good? That was completing the square. Whatever steps you need to write down, go for it. There it is. Okay?
Will you
Oh,
let
I
us
always
use
use
our
Tron.
like our pink sheet? You let us use?
Your unit circle?
Yeah.
Yes.
If we stole our note card from our ha and ba and sock, we just like.
We're going to end up writing that on this page. So, I mean, you can probably use it. I don't really care, but we're going to end up writing all those rules on here anyway. Okay? All right, 36. I to the 25th power, I want to break him down. I don't know what I to the 25th power, but I know that I is equal to the square root of negative 1, and I know that I squared equals just negative 1. Okay? So I want to break this down in terms of I squared. Okay?
I to the 24th.
I squared to the,
24.
not 24th,
1.
To the 24
Wait,
or
wait,
to
wait.
the 12.
to the 12th, because that will give me 24, right?
I squared to the 12th.
That gives me 24, but then I need one more, right? I need an I to the first hanging off, right? To give me a total of 25. Now, if it's an even power, you don't have to hang the I off to the side. You would just do I squared to the 12th, or I squared to the whatever power, right?
So if the 12 is even, then it's just then it's positive.
Then
If
it's
it's
positive.
odd, it's
Mhm.
negative.
If it's odd, it's negative. Mhm.
That's it?
So-
I just did it like that?
I
No, 'cause
squared
it's-
is negative 1, right? And what's negative 1 times itself 12 times? An
One.
even number of times.
1.
It's just going to be positive 1. So we have 1 times I, which is just
1 I.
1 I. Okay? You see how that works?
Okay.
Everything in terms of I squared. Because we can break him down, okay? All right, good? Happy with that?
Negative 1. What? Oh.
Yes. In theory.
Why'd I put?
Okay. Good, good.
Write the quotient in standard form.
Okay.
Rationalize.
This is a rationalize because we don't like the bottom.
I don't like that.
We don't like the I in the bottom. Okay. So I have to multiply by
3 plus 7i.
3 plus 7i.
Thank goodness.
And 3 plus 7i. Not because that's what the top is. That's a terrible coincidence that that's exactly what the top is. But you multiply by 3 plus 7i because it's the conjugate.
9.
Conjugates. Okay? Alright, so on the top, when we FOIL, multiply, so we get 9 plus 21i plus another 21i.
I squared, which is.
And then
negative
7i and
1.
7i is 49i squared, you said, yeah?
Negative 1.
Okay?
50.
Alright, I squared, though, is negative 1, which is going to make this minus 49, yeah? Okay, let's finish the top before we move on to the bottom. So 9 and negative 49 is negative 40
Negative 40 plus 42.
plus 42i. Perfect. There we go. Now, if my bottom number comes out to be a number that's divisible by 2, I can reduce that, correct? Okay? All right, so we're looking for a number that's divisible by 2. Maybe, okay? Here,
Which part cancels?
we're going to have 3 times 3, which is 9, right? And 3 times 7i is 21i,
Oh,
but then negative 7i and 3 is minus 21i, okay? So if you don't want to write those middle two pieces, if you know they're going to cancel, that's fine. What's negative 7i and positive 7i?
Minus 49.
Minus 49i squared, but it will actually be plus 49, okay? So the 21s will cancel, and my bottom number will be
58.
58, okay? Can I reduce?
Yep.
Yep, all of them are divisible by 2, so negative 20 plus 21i over, what's 58 divided by 2?
29.
29. Will that reduce any further? No, 29 is prime. The other ones are not, but 29 is prime. So, for sure not reducing. From there, anyway. Okay? All right, good.
Get off your phone.
Tori's coming, 18.
Kind of cute, but not really.
Okay?
Yeah.
Who is?
Tori.
All right, 34, quadratic formula. Okay, quadratic formula is, if you want to write down the formula, here it is.
Negative b
Yeah.
plus minus the square root
Negative
of
b
b squared minus 4ac
All over 2a.
I had a
Perfect.
question on the ACT about this, and I could not remember if it was negative b squared or b squared.
Yeah.
It was killing me.
But it doesn't really matter. Like, if it is negative b squared, if you
Oh.
take the b and square it, it's going to end up turning it positive anyway, right?
Oh yeah.
So, anyway.
Sarah still
Alright.
probably got it wrong.
It was like figure out what this girl did wrong, and then I was like, okay, let me write it out, and I was like,
I had that
oh.
exact same problem, but I got it right.
Okay, so,
you don't know that.
the first thing to make sure is that everything's on the same side of the equal sign, right? And it is. It's ready to go. So, a is 5,
Negative.
b is negative 2, and c is 6, okay? All right, so what's negative b look like?
2 plus or minus
Positive 2,
4.
okay? B squared is 4, minus 4 times a times c is 6, all over 2 times 5. Okay, then we reduce from
30
there,
times 4.
okay?
Yo.
2 plus minus.
The square root of
Okay, 4 times 5
Negative
times
160.
6 is 20 times 6, which is 120. Is it positive 120 or negative 120?
Negative.
Negative 120. But it's 4 minus 120.
116.
Negative 116. Does 116 come out nicely?
No.
No, we're just going to leave it like that. Okay? 116 might break down. I don't know. Maybe it does.
over 10.
But we're going to leave it. We're going to leave it.
Could
Can
you
you divide
by
all of them by
2?
2?
No.
Not if the 16 is still inside.
Okay.
So what we're going to do is we're going to do 2 plus and minus the square root of 116i all over 10. If you get it to that point, I'll count that answer right. If you want to break the 116 down, I know for sure 4 goes in there. Right? 4 goes in there, 25 plus 4, 29 times, I believe. 4 and 29. So
Oh.
this would be 2 square roots of 29, right?
What?
2 square roots of 29i.
I'm just gonna leave it.
Now I can divide everything by 2. Okay, so this would be 1 plus and minus the square root of 29i all over 5 is what it would be. So if you want to get it to that point, that's fine. I won't make you reduce it further than like the green one. But
So I have a question.
you can't divide by 2 unless
Why is
the
that one
1/16 part of it's on the outside. What?
So this note card you let us use a couple, whatever ago, the one that has like the vase and the haws. Can we use this instead of
That's
writing
exactly what Kyle just said.
instead of writing it all down? And what did you say?
She
And I
said
said we're gonna write it all down in that sheet anyway. Okay. Good? Alright. Find the horizontal asymptote. 33. Ha's. The rule for Ha is to look at N and M.
You probably killed him.
Okay, let's talk about what N equals and M equals. What is N, by the way?
2.
N is 2, but what is it? What are you looking for on it?
The degree
The
on the top.
degree of the numerator,
I'll be scared of boys.
and this one's the degree of the denominator.
Did we do P's and Q's in
That's
here?
why I have so much energy.
Did we do P's and Q's?
I can't remember what is the P's and Q's for? Oh, that's a
To
stats
list,
thing,
to
isn't
li-
it?
no,
Oh,
no, no, no.
plus minus
That's
this,
to
plus minus
list-
that.
That's to list the possible rational zeros. I don't think,
Let me
I think
see.
we did. We used to have like.
I don't see any of them on here.
It's not
We
on
might
here.
have done it at one point, but I don't remember. I don't have any of those, any
It's
P's
not
and
on
Q's
here.
on here. Okay? Alright, the degree of the numerator was 2. The degree of the denominator is
1.
1. Okay, here's your rules. If n is less than m, if n is greater than m, or if n is equal to m. Here's the rules. If n is less than m, your Ha
Y equals 0.
is y equals 0. If n is greater than m, he's top heavy. He falls over, so he does not have a 1. He is none. What happens if they're equal?
The leading coefficient over the leading
The
coefficient.
leading coefficient of the leading coefficient. That's the rules. Okay? So this one, for a Ha, will be
Y
Does
equals
not
0.
exist.
Oh wait, no, none.
None.
will be none. He's top heavy. He'll fall over. So he will not have a horizontal asymptote. No horizontal line. Okay, and there's your rules. Got it? Okay. All right. Let's skip to 31. I don't know why I give you 2 horizontal asymptotes.
What?
Let's skip up to 31 real quick, and then we'll come back down to 32 while we're on N and M. Okay, what's N for the top?
2 and 2.
2. M is 2. So I look at Y equals, what's the leading coefficient of the top?
1.
1. Leading coefficient of the bottom?
1.
So Y equals 1 over 1 or Y equals 1. That's the Ha. Do you know what Y equals 1 looks like for a Ha?
Just 1 of the
Just-
cross.
Like right here, this is
Yeah.
what your Ha will look like. Okay, just FYI. Okay, just so you know what we're finding. Okay, all right, vertical asymptotes. How do you find vertical asymptotes?
To 0, but you have to group.
Set denominator, whoa, equal to 0. But did you hear what Rachel just said?
Break it down.
Beware of
Holes.
holes, because a hole will look like a va, but it's not a va. Okay, so we're going to break down the top and the bottom just to make sure that one of them's not a hole. So the top breaks down as a difference of squares
One
into
is
x plus 2x minus 2.
x minus 1.
Okay, the bottom
Oh, there's one.
the bottom is 5. Multiply to get 5, add to get negative 6.
X minus 1 x
Yep.
Minus 5 minus 1.
There's no.
Okay, so my possible vase would be at x equals 5 and x equals 1. Do either of those cancel?
No, ma'am.
No, they're both vase. Vase. They are both vase. None of them cancel. If one of them canceled, it would be a hole. Got it? So beware of holes.
Stop, please.
Okay. Good?
That's my sleep.
All right. Okay, ready for 30?
Asymptote.
30 is another I thing.
Finish chapter 2 and then be done.
Sure.
Is that okay?
That's fine. I don't care. How many do we have left for? Yeah,
Wait,
yeah,
what
that's
time
fine.
do we get out of here?
We don't got enough time for that.
We got it at 50. So we've got like 8 minutes left or something.
Yeah, we can keep going.
All right, here we've got 4 minus. What's the square root of negative 25?
5i.
5i. Close parentheses. plus 2. And what's the square root of negative 9?
3i.
3i, but what's the
times
2 doing?
6i.
So, yeah, 3i, this would become 6i. Agreed?
Yep.
Minus 4i plus 7. Okay, what about these parentheses over
They
here?
go away.
Wait.
The-
That's 6i.
Minus 4i plus 7.
Thank you.
These parentheses
Go away.
are not doing anything, right? Like there's nothing to multiply it, so like they're not doing anything. They're just like being a barrier. So now we just combine like terms. So 4 and 7
11.
is 11, okay? Negative 5 plus 6 minus 4.
Negative 3i.
Negative 3i, there you go. 11 minus 3i. Good, good?
So you
Good.
just simplify.
You're just simplifying. Yep,
Yeah, it's just
yep, it's just a simplified one.
basic algebra.
Okay?
Just addition,
Wonderful,
subtraction.
wonderful. Okay? All right, 29. Divide.
Long.
I do not specify long or synthetic. You do what you want.
Synthetic.
You want to do
This one
synthetic?
have to do
Yeah,
this.
yes.
This one.
I got to do this one.
Now, you don't have to do this. You can do the synthetic, but what's your number going to be on the outside?
1/2.
1
That
half.
actually won't be too terrible.
Yeah, as long as we're taking halvesies of like odd numbers, or even
Please
numbers,
don't
I mean.
say halvesies.
Halvesies. Do you want to do it long or synthetic?
Synthetic.
Because
Synthetic.
synthetic is easy and that half scares me.
And that half scares you. How about I do both ways? Okay.
Oh,
So you pick.
man.
You pick. You don't have to write both ways down, but you pick. Okay.
Well, we have to do.
So I will not specify until
but
you.
will you give us x squareds and stuff like that?
I don't know. I don't think so.
Can we see the test?
Will you do both so we can write how to do both down?
Yep. I'm gonna do both on here. Yep.
Can we
So let's do
can we see
synthetic
the
first.
test?
Yes.
Hey,
So I've got 1/2 on the outside.
Hey.
Do I need to put zeros in?
No.
6, 7, negative 15, 6. What's that?
What if you have like a half of an x?
What you talking about?
0.5x.
Is it like legal to have
Yeah.
a half an x?
Half-x,
you
do that
won't.
for slope all the time.
You won't.
Y equals 1/2 x plus 7 or whatever. You have half x all the way, or
You won't on here.
Oh, that's 4.
Okay. What's half of 6?
3.
3. So 7 and 3 makes.
Wait, I'm lost.
And-
I missed where are you?
6,
You're fine.
Three.
Half of 10 is 10.
Okay.
5,
Half of 10 is 5, and this will be
Negative 10.
negative 10, and half of negative 10 is
Negative
negative 5.
1.
So your remainder is 1. Okay, now
6x
we're taking
squared
6x.
x to the third divided by an x,
X.
so this is x squared,
minus
x, and number.
Plus 1 over 2x minus 1.
done. Easy peasy. Squeeze them
Minus
Over
in.
10.
2x minus 1.
Plus original.
There it is.
To get the number you divide by for synthetic, you just set it equal to 0.
Equal to 0. Yep. Some of them you can do in your head, but some of them, like, if you need to, write it out, that's fine. Okay? If you want to write down long, here is long.
I guess.
I guess.
This is why I will never enjoy it. Never.
Oh, please. You don't even know what's good.
Why does math?
All right.
The only thing that has a solid answer, like English.
Yeah,
I don't
right.
understand,
Yeah,
but
exactly.
math,
Now, if
you're always
it's
gonna get
infinity,
something.
then it could be any.
It's still a solid.
But it's still one
It's not
answer. Oh, why am I doing that? I don't even know. 3x squared. Switch your signs.
I'll graph number 27 while y'all do that.
Oh boy, I screwed up. I think we screwed up.
What?
We screwed up.
Did we screw up?
We screwed up. We
Where?
have to have screwed up.
How did we screw up?
Because our answers are already different.
How are our answers different?
So we have 3x.
Do you disagree?
Those are like divided
Oh, why?
by 2. Those are divided by 2.
What the heck? What the heck?
I'm puzzled. Okay, let's keep going. We're gonna keep going. We're just gonna keep going.
Wait, what? Maybe you just divide
No,
everything by
no,
2.
just wait. I'm gonna show you. We're
or
gonna keep going.
multiply everything by
He's gonna
2.
show us Luke.
This is interesting.
Plus
Don't say
Minus
that.
plus.
5x.
negative 10x plus 6. Okay.
Hold on.
And negative 5 times, maybe. Negative 10x plus 5, so minus 5, which is 1 here. Plus 1 over 2x minus 1. Yeah, because this is just double what that is.
No, it's not.
Yeah. Well,
It's got the same
without the
remainder.
remainder. The remainder doesn't count though when you double it. So yeah, technically this piece and this piece are the same. One of them is just scaled up.
But that's not the same.
Um.
I don't care what you say. That's not
Well,
the same.
So the functions are not the same exactly, but they'll have the exact same like zeros when you factor them down. Right? Like if I have 2x plus 4, let's say, right? And I set that equal to 0, right? Okay. I would subtract the 4 divided by 2 and x equals negative 2, right? That's going to have the same answer as 4x plus 8 equals 0. Agreed?
Yes.
Okay. So yes, those two functions aren't gonna be exactly the same. I didn't put that together. Okay, so the functions won't be exactly the same, but they'll have the same zeros when you go to break them down again. Okay.
So you will give us.
So I a little bit lied. So I will take both answers. Like they're both technically the same answer. Because they'll have the same zeros. So very weird, very strange.
Hey.
I'm glad we did that both ways. Okay. 28.
We got one.
I just got the worst ringing in my ear. And
Oof.
It's so painful.
Oof. Are we gonna have time for this one? Okay.
This is
If these are my zeros, what do I do now?
I don't know.
Oh,
What?
X plus 2.
X plus 2,
X plus
X minus
2,
1, X minus 3.
X minus 1, X minus 3. Okay? All right. FOIL, just the first two.
X squared plus X minus 2.
Why'd I do that?
Okay? Then you FOIL with the second piece. Or
X
the
to
third
the
piece.
third minus 2x squared minus 5x plus
X
6.
to the third minus 3x squared plus another x squared minus 3x minus 2x plus 6.
X to the third minus 2x squared minus 5x plus 6.
Wait, what?
X to the third minus 2x squared plus 5x
Minus 5x
minus
plus 6.
5x plus 6.
You can look at my work if you need to. All right, we might have to stop there. The next one's not a long one, but we're gonna run out. Well, we're gonna run out of time. Okay. Very nice. So we got a little bit more than 15 done, which is good. Okay. Good. That one's just a foil. All right. Beautiful. Okay. Goodbye.